Hello, everybody. Hope you're all having a fantastic day. Today we're going to be talking about quadratic applications, so let's jump right into it. First, though, if it looks as though my paper already has stuff written on it, that's because it has. And about halfway through recording this, my camera just decided it didn't want to work with me anymore and just went on strike. So we've hopefully fixed the problem, and now we're back. So Texas Instruments, the guys who make this thing, has found out that by selling TI-83 graphing calculators, that the revenue is a function of the price. The revenue is a function of the price according to this equation. And what I've done here is I've gone into my y equals menu, typed in that equation, and then I just played around with the window until I found something that worked. Now this is pretty big. It's talking about revenue from calculators, so I knew my values would be pretty high. I went ahead and went from a negative 10 to 150 and a negative 10 to 800,000. And what I found out here is that my parabola fits really nice in there. And again, that's just from playing around with it. There's no secret trick to that. It's just from playing around with it. Now, if you notice, I did leave a space in the negative side, and that's for this reason right here. Let's say that I want to find my zeros of this function, which I will have to, because on here I'm going to want a graph. So my zeros for the function happen when it crosses the x-axis, but it asks for a left boundary and a right boundary. Well, in order to go to the left and right of a zero, you have to go above and below the x-axis. So I'm going to need a little bit of space below the x-axis. That's why my window has a negative 10 in there for the minimums. So just keep that in mind. For the a couple of things here. For this zero over here, if you plug in 0 for p, you get 0 squared times 150, which is 0, plus 21,000 times 0, which is 0. 0 plus 0 is 0. So one of the places where it's going to cross the x-axis is going to be 0, 0, which makes sense. If you don't charge any money for your calculator, you're not going to make any money. Down here, we have the price of the calculator. On the side, we have the revenue that will be made. So if you charge $0, you're going to make $0, funny enough. So let's find the other one here. Let's see, we've got, ooh, I shouldn't have done that. Let me just type this in here. Alright, so I'm going to say my left boundary is right here, right at 100 units, or $100 per unit. And then my right bound, I'm going to keep scrolling until I see this y value go negative, because I know I want to go below the x-axis. So I'm going to scroll. Oh, there it is, negative. Enter and enter. And you find out that $140 will give you a $0 revenue. So over here, if I charge 140 bucks, I'm going to get 0 for revenue. Now I want you to think about this. You got 0 to the left, 140 to the right, and the shape is a parabola. Well, what would be right in the middle of that, where the vertex is? The middle of 140 and 0, which would be 70. And so here's what it's going to look like. Something like this. Nice and even. Just like that. And then we can figure out what the maximum value is right here. We'll probably need to do that in just a moment. So let's go ahead and figure it out anyway. Now there's two ways you can do that, obviously. You can find your maximum with second calculate. Number 4 is maximum. And then do your left and right boundaries, like we talked about on Monday. There, and there. And your max is 69.9999996. Now, depending on your calculator, this may show up as 70. That makes sense to me because halfway between 0 and 140 should be my vertex, 70. And the max from here is $735,000. So let's talk about this. This is going to be 70, 735,000. I'm going to need that in a minute. My domain goes from 0 to 140. I can't give money away, so I'm not going to have a negative price. I also can't charge more than 140 because I'm not making any money. So it's 0 to 140. It touches both of them. Range is 0 to 735,000. All right. So what should TI charge in order to maximize revenue? Well, they should charge $70 because that's your maximum. If you charge 70 bucks, you're going to maximize your revenue. Now, this makes sense here because if you charge more for a calculator, like if I showed you this calculator and I said this can be yours for $70, that's a pretty good bargain considering this one right here actually goes for about 120. So that's a good deal. Yeah, I'm going to buy one. On the same note, if I come up to you and I say this can all be yours for the low price of $750, there ain't no way you're going to buy one. So the higher that they charge, the less money they're going to make. On the flip side of that, if it costs me $50 to make this and I only charge $60, then I'm going to make less money. But if it costs me $50 to make it and I'm going to charge $70, I'm going to make more money. So there's a fine balance between pricing on that. And then what is the maximum revenue? Well, that's $735,000. That's the Y value. What would the revenue be, or what would the revenue be if they decided to charge $100? So let's say they bump the price up to 100 from 70. Let's hit trace and 100. They would get $600,000 in revenue. So just for raising the price of a calculator $30, they're making $135,000 less. It makes sense. People don't want to pay a lot of money for a calculator when they can pay a lot less for one. And the last question here says, what other price, what other X value will yield the same Y value, the same revenue? So I'm going to do this one a little bit different here. I'm going to go to Y equals, and I'm going to scroll down to Y2 and type in 600,000. One more zero. And that's going to let me go through and figure out, this is $100, right? I need to find this guy. So second trace, number 5 for intersection. Scroll a little bit closer to that, to the left intersection. Enter, enter, enter. 40. Makes sense. Oops, $40. Now that makes sense to me because $30 more would be 100 and I'd be up here. $30 less than 70, I'd be at the same Y value. So yeah, makes sense to me. All right, let's go to the next page. Now I'm going to try and get through this a little bit quicker here. It says the cost C in number of cents per kilometer of operating a car is a function of its speed in kilometers per hour that the car was driven. This relationship is represented by the following function. So let's go ahead and type that in your calculator if you have that handy. I'll go through and show you the window workings on this. 0.01 x squared minus x plus 37. Obviously I don't have an s, so I'm using x. Alright, so I've got that typed in. Go to my graph here. It's going to be all kinds of weird because this is going off my other problem. So let's do this. Let's go my window. Just for kicks and giggles, let's change this to 150 and see if I'm anywhere in the ballpark. Oh, yeah. Looks good. I like it. Now, before I commit to that, I'm going to go down here and I'm going to say, what are some values I'm going to need to find? So 20 cents per kilometer, 150 kilometers per hour. So I'm going to need 150. So you know what? I'm going to bump this up. My window, I'm going to go to 200 on my X's. All right, so while that's graphing, let's go ahead and get this thing set up. Domain would obviously be 0 to infinity. Let's figure out where this thing crosses the y-axis. So I'm going to hit trace, 0 for x, and 37. So at 0, comma 37, you have a y-intercept. And then let's look at minimums, and then we can go ahead and plot the graph and see what it's going to come up with. So second trace, number 3 for minimum. Left bound here. Right bound about here. Minimum is 49 point all those 9, so let's say 50, comma 12. $50, 12, and it's going to do something like this. This is your speed. This is your cost. Speed is kilometers an hour. Cost is cents per kilometer. All right, so your domain is going to be 0 to infinity. It's going to keep going there. It's never going to stop. Realistically, your range is going to be the lowest point here, which is 12 to infinity. Okay, it says, how much would you spend to drive at 150 kilometers an hour? So hit trace, 150. You'd spend 112 cents. So that's your X is 150, right? So that's your cost is 112 cents, or what is that, $1.12? Between which two speeds must you drive in order to keep your costs no more than 20 cents per kilometer? So I'm going to go into y equals y2, 20. And I'm going to find these two intersections. All right, I'm going to find these two intersections. So I've already done this ahead of time just for the sake of time here. 21.716 kilometers an hour and 78.284 kilometers per hour. What speed should you drive to have the lowest cost? Well, that's where your minimum is at, 50 kilometers per hour. And that just came from your minimum. All right. Now, what I'm going to do for this part, because this video is getting a little bit longer than I wanted it to be, what I'm going to do is I'm going to save this piece, and I'm going to have you do this in class with us. All right? I'm going to have you save this last part. We're going to go through and make a scatter plot and talk about regressions. Now, you do have how to do that on the back here, so we're going to go through and just kind of talk about that when you get into class tomorrow. Have a good one.